All right, we're going over the final quiz questions real quick. So I'm going to do these in 6 segments, one little short video for each one. So 19.1, here we're looking for field measurements in feet for irregularly shaped sodded area as shown in the figure 19.20. So we're going to look at this using the trapezoid method. The quiz, I believe, is not being more specific than that, so theoretically I'm going to show you both methods, and then you can kind of pick and choose which one you use to select the right answer in the quiz. So first we have this trapezoid method, which is the 1/2 the base times height plus the base times h1 plus h2 divided by 2, ... So you do all 5 of those, or all 5 more of those trapezoids plus that last triangle. Sum all of that up, that's how the calculations show. Adding all that up, I got 2487.5 cubic feet, and then divide that by 9. So again, there's 9 yards squared, or sorry, not the right way to do that. So 1 square yard is 9 square feet. So divide by 9 gets us 276. The other method is the what they call the Simpson's 1/3 rule. Not something I've ever actually seen in the real world, but it is technically a method here. So we're going to go ahead and round those numbers out. So this formula is kind of funky. It's the first, the last, plus 2 times the sum of the odd, plus 4 times the sum of the even. And so what they mean by that is literally you're going to number these up. 1, 2, 3, 4, 5, 6, 7, 8. So that's your first, that's your last. Odd, odd, odd. Even, even, even. So all we're doing is we're just adding those numbers in that column for this method. That's how that shows right there is the bottom of that. 1/3 times 20 times 15 plus 14.2 plus 2 times 43.3 plus 4 times 60.3. That gives us 2380 square feet. Divide that by 9. Got somewhere in the ballpark of 264 yards. Okay, moving on to problem 2. Field measurements in feet for an irregularly shaped paved area are shown in figure 1921. Calculate the area and pavement to the closest square yard. That's kind of important there. Again, they give you all these measurements in feet. So we're just going to have to divide that by 9 since we're working in square areas at the end of the problem. So that's area of the triangle is this square root of s times s minus a times s minus b times s minus c, where s is a plus b plus c divided by 2. And then the area of the portion of the circle is just that angle divided by 360 times pi r squared, r being the radius. So you can see we did the blue triangle first. So that's that square root of 53.7 times 53.7 minus 31.2 times 53.7 minus 41.9 times 53.7 minus 34.3. Square root of all of that, I got 525.92. Did the same thing on the green triangle. So again, same calculation, same formula. Plug and chug your lengths there. That one came out to 695.97. The last piece is the pi times the radius squared. So the 100 degrees divided by 360 times pi times 45.2 squared. Got me 1782.88. Add all 3 of those up, and you got 3,003 square feet. But again, they asked for it in yards. So divide by 9. And that's what gets you that magic number. Okay, moving on to problem 3. So refer to figure 1922, calculate the end areas at stations 3 plus 60 and 3 plus 80, and then determine the volume in cubic meters of cut required in that section of road. For the end area at 3 plus 60, use 180 meters as the datum elevation, and for the end area at 3 plus 80, use 181 as the datum elevation. So kind of moving along here. Really, how we're going to break this up is just like the like what we're actually going to do in the next problem. Actually, is just using the trapezoid method. But effectively, we're going to get two areas. With those two areas, we're going to average those two together to create an overall average, and times that by the depth. So in this case, the depth is along the stationing. So how we're going to attack this first is literally just go in here and find all of these nodes. So we're going to use interpolation to calculate some of the nodes that are missing using the rise over run formula. And from that rise over run formula, we can come in here and we can appropriately calculate the average area. So you can see what I've done through here is all I've done is I've dimensioned everything out, again, using some of that interpolation techniques on each one of these pieces. So you can see I broke this up. I've got triangle, triangle, trapezoid, 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 trapezoid. So 2 triangles, 4 trapezoids, and that's what you're seeing reflected here. And those are all corresponding to those different colors that I got there. The triangles are shown here. Those are simple. 1/2 base times height. Again, trapezoid formula, h1 plus h2 over 2 times width. Adding all of that up, I got the sum of 24.046 square feet there. Or sorry, that should be meters. Watch our units. NASA had a big thing a bunch of years ago about one group that was working in feet and another one was working in meters, and they accidentally calculated and forgot to change the units on something, and they ended up sending a rover to the wrong planet. Well, basically it didn't get to the planet they were intending it to get to. Okay, so that's the first piece. I'm not going to show you all the math on the second piece because I want you to do some of that yourselves. But if you do that piece appropriately, the area that you should get should be that, 16.026, something like that, in that neck of the woods. You're going to average those two out, divide by 2, multiply that by that length of 20 meters, and that you should get, roughly 400.66, or somewhere around that number. Your decimal point's going to be a little bit differently depending on how you rounded as that final number. And that's the problem. All right, moving on to question number 4, 19.4. So using the prismoidal formula to compute the volume in cubic yards of concrete contained in the figure. So they give us kind of the base in the end, so we're going to interpolate the middle. So how we do that is fairly simple. So all we do is so that piece and that piece and that piece are all 6, so that's 6 and that's 6. So interpolating them in the middle or midpoint is still going to be 6. So the height starts at 6 and 11. So 6 plus 11 over 2. 17 divided by 2, so you got 8.5 there. The base, 7.5 and 11, so 7.5 plus 11, divide that whole thing by 2, is 9.25. Okay, moving over to the actual calcs here. So we're going to use this volume of the prism formula. So length times area 1 plus 4 times area of the mid plus area of the end, all divided by 6. And that thing calculates, so if you do the area 1, that's 7.5 plus 6 divided by 2 times 6. So that's the base 1 plus base 2, or sorry, width 1 plus width 2 divided by 2 times height is 40.5. The area 2 is 11 plus 6 divided by 2 times 11, so 93.5. Area mid is the 6 plus 9.25 divided by 2 times 8.5, so 64.81. So adding those all in here to our main formula here, the length is the 25 here, times 40.5 plus 4 times 64.81 plus 63 or plus 93.5, divide all that by 6. The number I came up with is 1638.5 cubic feet. And they asked for it in yards, so you divide that by 27 and you get 60.68 cubic yards. And that's the problem. Okay, next question, 19.5. Stockpile of highway crushed stone into a shape of a conical figure. The base has a diameter of 72 feet and the height is 52.5. Compute the volume in cubic yards of stone. So they gave us the measurements in feet and they're asking for it in cubic yards. So we're just going to have to divide by 27 to get to that. Relatively simple. So here's how that draws out. We have a height of 52.5. They gave us a diameter, so we're just going to do it in radius. So divide diameter by 2 gives you the radius. Formula for volume there is relatively simple. Pi r squared times h over 3. So pi times 36 squared times 52.5 divided by 3. Came up with roughly that number. Okay, moving on to the last problem. This one's kind of a fun one. You got basically what amounts to kind of like a bridge abutment of some type. Compute the volume in cubic yards contained in the footing and abutment shown in figure 1924. So just kind of like the other ones where we break the shapes into, kind of weird shapes into smaller, more consistent shapes. We do the same thing here. So we take that base, we convert that into a simple trapezoidal, or in this case, rectangular prism. Same thing with the red box and the blue box. And then the only thing that gets a little tricky is we subtract out that pink section. Because even though you can't see it there because I've got that all drawn in, we have a section of that is recessed. So we have to subtract out that little bit of volume. Draw that guy back in there. So that purple bit that we subtract out's there. So that's pretty simple. We end up with our base. Base times width times height on the green section. Base times width times height on the red section. Subtract out the pink bit. Then we have, gets a little trickier here. You can kind of just do end average area method kind of on the same thing, right? Where you've got a known elevation, 494.5, 494.5, 493.5. Average height of that is 494 even. So you can kind of take an average height to take that into account. So all I've done is I've shown that formula here, 494.5 plus 493.5 divided by 2 minus 489 for the height. So that basically gives you that height of 5. So 2 times 48 times 5 gives you the 480 cubic feet. Add all three of those numbers up, gives you the total cubic feet. And did they want this in yards? They did want it in yards. So there's our cubic feet number. Grab the old calculator real quick. So 23 93 divided by 27